Let's do problem 21 on page 732 in chapter 23. Yeah, that's what you call the sound of sarcasm right there. All right. So here's the problem in the book. All right. Number 21, it says 4 point charges are at the corners of a square of side A as shown in the figure. Determine the magnitude and direction of the electric field at the location of charge Q, which is right there. And what is the resultant force on Q? And B is pretty easy. You get A. So here's the given, find, and solve of it all. We've got these 4 point charges. They're all equidistant apart. And we want to know what is the electric field on Q, and then what is the electric force on Q. And one of the things we can do right away is, let's just draw Q and try to visualize what's going on here. And we'll start with the 4Q. Well, they're the same charge, so they're going to repel. And this is going to be something like this. And here we have less charge, and it's farther distant, so it's going to be smaller. But it's going to be at a 45-degree angle, I think you can see. And then this charge is going to even less charge, but a little bit closer, so I don't know, something like this. And it's going to be to the right. So what we have to do to get the overall electric field is we have to add all of these together. So we have to figure out what they are, what their components are, express them in component form. And I believe it did say in the book anyway, it said determine the magnitude and direction of the electric field. So that means they want us to express the answer in polar coordinates. So I think what I'm going to do is I'm just going to label this 1, 2, and 3 just to keep them straight. So let's do E1. So the electric field due to the first charge, is let's see. Oh, I'm sorry, up here. First of all, the general electric field for point charges is E equals K Q over R squared. But now this is just the generic Q, not the specific Q in this problem. So you'd say, okay, well, what is the charge on here? It's K, and then it's 2Q over R squared, but R squared is just A squared. And then you have to say, okay, what direction is the electric field in? This is the magnitude of the electric field. What direction is it in? It's in the I hat direction. Now, E2 is a little bit more complicated. It's got a magnitude of K times 3Q over, now, if you think about this distance here is let's see, it's the square root of 2 times A, right? So you have to square that to get R squared. So it's going to be 2 times A squared. Now, if you want to get it in components, we're going to multiply by the cosine of the angle. And I'll do it this way. I'll just cosine 45 degrees, and then in the I hat direction, because it's going to push it that way, and then plus K 3Q over 2A squared times the sine of 45. So they're going to be the same value in the J hat direction. And of course, this is kind of a silly way to do it. What's the cosine of 45 degrees? It's just the square root of 2 over 2. Right? So the square root of 2 over 2. All right. Now what is E3? And I should put vector hats on all of these. Well, E3, well, we got K, and there's 4 Q's down here over A squared, and that's going to be in the J hat direction. So I got E1, E2, and E3 all in IJ form. So let's add them together to get the total. And well, let's do the I hat first. There's this and this. So well, so that's 2kq over a squared plus 3 root 2 over 4 times kq over a squared. And that's all in the I hat direction. And then this is going to be plus, and in the j hat direction you end up with well, this plus this, and you get 3 root 2 over 4. This is really tedious, I'm sorry. Kq over a squared plus this guy 4 kq over a squared. And that's all in the j hat direction. And then you can, well, you can add these together. Here we have kq over a squared, kq over a squared. So that stays the same, and then we can add the 2 plus this. And when you crank it into your calculator, and I've already done it, but if you just do the arithmetic and add this up, you get kq over a squared times 3.061 in the I hat direction. And then when you add this plus this, this is for Cade?
Yeah.
Cade, come on up and get your note. And this is kq over a squared times 5.061. Right there. Well, now you can just use Pythagorean theorem and inverse tangent with these guys, with just the coefficient. You can factor out the kq over a squared, and then just use Pythagorean theorem and inverse tangent. And what you end up getting in polar coordinates, and I'm just going to assume you can do that. And by the way, a lot of your calculators have a conversion from polar to rectangular coordinates built in. So I'm not going to, when I'm teaching vector addition and all that, I want to see that. But what you get is kq over a squared times 5.91. I mean, when you take this squared plus this squared, take the square root, you get 5.91. And the angle, when you go 5.061 divided by 3.061, take the inverse tangent of that ratio, you get 58.8 degrees. And that is your answer. So it's kind of tedious, but it does, I don't know, it's not too bad. Any questions? Okay, that's all.